Hello, yeah, in this video, I want to show you how to perform cluster analysis using the cluster package in R. Okay. So there's many cluster analysis packages in R. We showed you how to do cluster analysis using k-means and h-cluster function in base R. But if you want to be more sophisticated in cluster analysis, there are specialized packages available in R. And one of them is called cluster. Okay? So this package contains many functions. It's quite comprehensive. Okay? I'm not sure I can cover each and every single detail in this package. So I'll try to give kind of a broad view for this package. Hope you can learn something from this video. Okay. So first, let's just install it and then load it. And then we can set a random seed. And then we create a data set actually with 3 clusters from normal distributions. And first, I want to show you how to do a partitioning around Medoids PAM method. Okay. So this so-called Medoids, they are the initial cluster centers. So basically PAM iteratively reduce the total dissimilarity. There's a measure for that until the cluster stabilizes. Okay, that's how it works. And one strength of PAM is it's not sensitive to outliers in the data set. Another strength is the distance can be very flexible. You can use many different types of distances. So since this is method in which you have to specify the initial data points, you have to tell R how many clusters you want to use. So here is the PAM, then data, and k equal to 3. So that's we tell PAM there'll be 3 clusters. Okay? And then we can print out the Medoids. So basically these are the centers of the data points. And then we can use the class plot function to plot out the PAM clustering. So it look like that. Again, we cheated when we create the data set, so make it very easy to separate. Okay, so this is what it look like. You got 3 clusters there, and we got the observation numbers there. Okay. All right, the next one is called the CLARA, or clustering large applications. So in our sample data set, the sample size is not very large. So the computation went very fast. But if we have very large data set, then PAM can be very time consuming because every time we do an iteration, we are doing the computation for the entire data set. Okay. So when the data set is very large, then we can use CLARA. Basically, CLARA draws smaller sample size, random samples of the larger data set, and then run PAM on that random sample and put them together, and then do the iterations and then complete the clustering. So the syntax is CLARA data k equal to 3, samples equal to 5. Okay. And then you can print out the Medoids here, and then you can visualize the clustering. Look like it's very similar, the 3 groups. And also, you can compute the dissimilarity measures, and it's called the Gower dissimilarity for mixed data. We did not really talk about the type of data we can use for cluster analysis. When we generate data, we assume they're continuous, like from normal distributions. But if you have like both categorical and continuous data, we call it mixed data. And you can use actually the Gower dissimilarity to generate dissimilarity measures and use that for clustering. So we can set another random seed, generate a data set with mixed data. Now you got the continuous and you got a categorical variable. Then you can use the DAISY function. So the DAISY, the mixed data metric to Gower, okay, and put them into Gower underscore dist, and then you can print out the data matrix, look like that. Okay, and then with that dissimilarity matrix, you can feed it to the hclust function, and you can specify method equal to average, and then you can plot out the hierarchical clustering using the Gower dissimilarity. Okay. So you did this hierarchical clustering even if the data are mixed type. Okay. All right, and then we have the agglomerative methods in hierarchical clustering, and there are here we experiment in 4 types of method: single, complete, average, and ward.d2. Okay. Put them into methods, and then we split the graphic window into 2 by 2. So, and we plot out these 4 hierarchical cluster dendrogram using 4 different type of methods. Okay, and reset the layout. Next topic is called the CLHOT analysis for PAM. CLHOT analysis for assessing the quality of the clusters. Okay, so it will compute something called the average CLHOT width. When this measure close to 1, it indicates good quality. If it's close to 0, that means there's some overlapping. And if it's negative, then there's some misclassified data points. Okay. And also it will generate the CLHOT plot, which are basically bar charts of all the data points grouped in clusters. And you can also see similar information from the plot. Okay, so let's generate that using the CLHOT function, and then we can plot it out. It looks like that. Okay, so you can see there's 3 clusters in different colors, and the bar charts. So you can see they're very much close to 1. The average being 0.87, 0.88, 0.88. So they're pretty good quality clusters in this case. Okay. And we can also calculate the agglomerative coefficient to evaluate the strengths of the hierarchical clustering structure. Here, when we use this function, I found out the method here. So we're using the agnes function. There's no ward.t2, a d2 method. So it's only the ward method. So I change the method vector, the 4th component into ward, and then we run that. And you can see the agglomerative coefficient for all 4 methods. They are 0.967, 0.988, 0.981, and 0.998. Very close to 1, so indicating very good cluster quality. Okay. Next one is the FANNY, the fuzzy clustering. The key of FANNY is that the data point has potentially partial membership to multiple clusters, so it's a fuzzy. So this is more realistic, especially with overlapping data points. The previous clustering method, they dictate one data point must belong to only one cluster. Okay, but when you have a data point close to several clusters, and they will confuse the algorithm. Okay, so let's do FANNY. So this syntax is very simple. FANNY data k equal to 3, and then we can print out the membership, and then we can visualize just like before. So this is similar graph, but now we're using fuzzy clustering. Okay. And also we can use the DAISY function for custom dissimilarity matrix. Okay. And we have many choices. So here we do the Manhattan distances. Okay, so Manhattan, and then print out the matrix. And we can feed that Manhattan distance into the H class function and specify method into complete and plotted that out. We got to the clustering method, hierarchical clustering using Manhattan distance. Okay. And that's it. So as you can see, the R package cluster is quite comprehensive. You can spend more time reading the help documentation and play with the sample data sets in the documentation in the package so that you become more knowledgeable about how to do cluster analysis in R. Thanks for watching.